Alright guys, it's Mr. Huyn here with another lesson using trigonometry. Just before we get into working on word problems, this is mainly going to be using trigonometry, which is SOHCAHTOA, if you guys want a quicker way to remember what trigonometry encompasses for this unit. Um, you gotta make sure you read these problems pretty carefully. It's pretty consistent on how to set things up, but when you're having so much information on the word problem, you want to make sure you're like underlining key numbers and information, as well as using that information to draw a picture, because it's going to save you a lot of time in terms of trying to figure out these problems. So take my advice, draw the picture, and then set up the problem using trig. Alright, so I'm going to do a couple in each section. So we have angular elevation, which is part of our first section. So we'll do two problems in here, and then we'll move on to angular depression, where I'll do another two problems. Alright, so let's go ahead and start on number one. Right, so number one states Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, really important information, how far is he standing from the base of the lighthouse? So we know that Casey, and again, not everything's going to be drawn to scale, right? So for number one, we know Casey is a 6 foot tall individual, right? So I'll put that right there. He's a 6 foot tall person. And he is sighting that from the very top of the lighthouse, which is going to be 84 feet, so we'll have a lighthouse. That's going to go ahead and it'd be 84 feet. And he goes ahead and he looks from the very top in angle elevation, right? So for the angle elevation, you want it basically from the person's eyes, or wherever they are, to the very top of the lighthouse. And he cites that it's going to go ahead and be 58 degrees. And then they're wondering, well, how far is he from the actual lighthouse itself? So since we don't know the distance, which is from going from here to here, we're going to go ahead and call that x. Now, we've been dealing with right triangles, so we got to make sure we identify where the right triangle is. The right triangle is going to be right over here. Notice that from the side of the lighthouse to the horizontal line of sight, that forms a right angle. So right now we have a right triangle on the very top. But before we use trig, we need to go ahead, since we have a right triangle over here, we need to find the distance from here to here. Because we can't use the 84, because that's not going to be the whole side vertical length of the triangle. So we need to find this side, so that way we can use trig. So we're going to go 84, which is the whole lighthouse, minus 6, because that's the height of Casey. Believe it or not, number one is always the hardest one. That's what I'm doing for you guys. But the rest are pretty simple. You're not going to have to do any subtracting of lengths. You'll see that in a bit. So we're going to go 84 minus 6. So that means that triangle, the side of the triangle, is going to go ahead and be 78. So just to clean things up, because there's a crazy diagram right in front of us, we're trying to go ahead and find a missing side. I know that this is 78, right? Again, I'm just cleaning things up. There's so much going on in the very top one. I know my angle of elevation is 58 degrees. And then I'm trying to find the actual distance from Casey to the lighthouse. So I'm going to go use SOHCAHTOA. And since 58 is my reference angle, I'm given my opposite. And since there's nothing labeled on the hypotenuse, we're not going to go ahead and use anything with the hypotenuse. And then that means my third side is going to be my adjacent. Since I'm given my opposite and my adjacent, we're going to use the tangent function, because there's an opposite adjacent there. So solving for this, that's going to be tangent. My reference angle is 58 degrees. And then tangent's opposite over adjacent, so that's going to be 78 divided by x. And to solve for this, we're going to go ahead and do the switch. So that's going to be x is equal to 78 over tan 58. And remember, I set you guys up using the scientific calculator online. So let me pause real quick. I'm going to pull that up. All right, so I went ahead and paused the video and pulled up my scientific scientific calculator. So I'm going to put 78 divided by tan 58. So going over here, I have 78 divided by tangent. Remember, not the inverse because we're not solving for an angle, we're solving for a side. Tangent 58. Going to close it. So I have, if we're going one decimal place, that's 48.7. So over here, going back, the distance from Casey to the lighthouse is going to be 48.7 feet. All right. So that's how we're going to go ahead and approach these word problems. You guys know how to do it. It's just trying to translate the actual information onto a visual and then using trig. All right. Let's go ahead and do another one. And these become a little bit easier, right? So let's try number 4. So number 4 states a dog is standing 5 feet from a base of a tree, and it's looking up at a cat that is 16 feet up on the tree. What is the angle of elevation? So that should hint that the dog is looking up at the cat on the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? So it's a point on the ground. So let's do number 4. So I'm not the best drawer, but making it easy, that point, we're going to represent dog. And that dog is away from a tree. And then there's a cat up here with no body, right? So it's looking up, right, at an angle of elevation, and it sees it right there. We do know right now the dog is 5 feet from the base of the tree. So 5 feet is right here. And then at a 16-foot tree, they're asking us, since the dog is looking up at the cat, what is the angle of elevation? So we need to understand that there's a right angle created right here. So we're going to use some trig. And for this one, for the dog, we need to go ahead and use its reference angles to find, use the x to go ahead and find the side. So x is going to be across from 16, so therefore this is the opposite, making this is the adjacent. So we're going to use again SOHCAHTOA. So ka, got the H right there. Well, we'll just go ahead and just combine these here. Ka, toa. And since I'm giving my opposite and my adjacent, again, it's going to be one of those things where we use tangent. So it'll be tangent. I don't know my reference angle. My opposite is 16 over 5. And if you remembered, if tangent is attached to the variable, we need to switch to the other side. So let's bring this down. So that'll be x is equal to inverse tan 16 over 5. And let's put this into our calculator. So inverse tan 16 over 5. So inverse tan, let's clear this. Inverse tan 16 divided by 5. And that'll be 72.6 degrees. So the angle of elevation, x is going to be 72.6 degrees. All right, cool. Nailed those two. So you got 2 more from angle elevation. We just need to go ahead and do a couple problems from the angle of depression, and it's still the same process. So angle of depression is a little bit different from angle of elevation. It's only different in the sense of how you're drawing it. Now, if you look at the figure above, let me get this up here, right? If you look at the figure above here, the angle of depression is basically the individual is sitting up high and pretty and is looking down right over here. Now, we can do it a couple ways, right? It looks a little bit different, but if you have your angle of depression right over here, note that this is going to be your line of sight, and your point is looking down this time, right? And just for a quick tip, this is going to help you out huge, right? If you have an angle elevation and you draw a little figure that like a little box here, this is also going to go ahead and be congruent. Sounds confusing? Just wait for me to do a couple problems. So I got number 5, right? Number 5 says a lifeguard is sitting on a platform looking down at a swimmer in the water. So you have, and have a little, let's go number 5, little high chair right over here. and then you have someone sitting on here and is looking down at a swimmer, right? So got some water, you got your swimmer right over here, right? And the lifeguard line of sight is 8 feet above ground. So he is looking right over here, right? And he's looking down right over here. His line of sight is 8 feet above ground, right? 8 feet above ground. And the angle of depression, basically his sight looking down at the swimmer, right, is going to be right over here. So line of sight's right here, and then his visions. So that's going to go ahead and be 18 degrees right over here. How far is the swimmer away from the lifeguard? So they're asking you, what on earth is this over here? This X right over here. So that's how far is the swimmer from the lifeguard? So just to make things a little bit cleaner, I'm going to draw my right triangle. We'll relabel this a little bit neater. 8 right here. I know angle of depression is 18. And then I have X as well. So let's go ahead and solve it. So my angle, reference angle is 18 degrees. Over here, I have my opposite. Nothing labeled for my hypotenuse, but I do know that I need to find my adjacent. And this is going to be a little bit of a recurring theme on here. So Katoa, since I have my adjacent and my opposite, that means I'm going to use tangent. So I'll be tangent 18 degrees is equal to 8 over x. And since there's an x on the bottom, we're going to switch the positions. Okay, don't forget to switch. Bring this down. X is equal to tangent 18, which is going to be on the bottom, and the 5 on the very top. So 5 divided by tangent 18. So let's clear this up. 5 divided by tangent 18. Press enter. So therefore, for this one, you're going to have around, let's see, 5. Let's see, did I put the correct number in? Oh, you know what? I did not. Let's go ahead and fix that up. That should have been an 8. My writing was so bad over here. That's an 8 right over here. Okay, so my bad. So we're going to go ahead and recalculate 8 divided by tangent 18. So 8 divided by tangent 18. Press enter. So that's going to be 24.6. So in this context, x is going to be 24.6 feet. So the space horizontally is going to be 24.6 feet apart. All right, cool. Let's do one more, and then we're going to let you try. All right, let's do number 7. I know I marked down 6 over here, but last minute change. Let's do number 7. 7's a little bit trickier, so I want to guide you guys through it. So number 7 says building A is 400 feet tall and building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart are the buildings? So for this one right over here, we'll have one building right over here, right? This is the side. We'll call this building A. And then we know that one is going to go ahead and be 480 feet tall, right? 480 feet tall. We have a second building, 654 feet tall, building B. We're going to draw that a little bit larger, okay? A little bit larger. So this one is going to be building B. So they're asking you, well, how far apart are they? So we need to go ahead and find how far apart are they, given that we know that the angle of depression from the top of building B to the top of building A is 42 degrees. So if B is right over here, so the top of building A looking down, that's your angle of depression right over here because it's looking down from the very top, is 42 degrees. Right, so that's 42 degrees. Whoop. That's 42 degrees, right? Sorry for the ugly writing. How far apart are they? So we need to find this right over here. Now, earlier I taught you guys a little bit of a trick. Notice that the 42 it's pretty much everywhere right now, right? The 42 is not even part of the triangle, and the way I marked down the X is a little bit tricky. So we're going to go ahead and we're gonna go ahead and relabel some parts. This is just gonna be written a little bit neater. And so this right over here, because this is parallel to this is also gonna be 42 degrees. And so we have another right triangle over here. So let's redraw that. Right angle over here. That's 42. And that's the x. So things look a little bit easier to see. But here's the thing. We're missing a side. We know earlier that the distance from here to here, building B, is 654 feet. So we need to find the distance from here to here. So to find the distance from there to there, we're going to go 64 minus 480. So when you take those two, 654 minus 480, that's going to net you 174 feet. So this becomes 174 feet. So we're going to use trig again. So that's my reference angle. That's my reference angle. And so that's going to go ahead and be, well, going across right over here, that's my opposite. Nothing's written for my hypotenuse, therefore that third side must be my adjacent. And if you've been keeping up with the trend, since we have our opposite and we're trying to find our adjacent, that's going to be tangent 42 is equal to 174 divided by x. If the x is on the bottom, you're going to do the switch, so it'll be x is equal to 174 divided by tan 42. And so when you put that into the calculator, let's go back to our scientific calculator. That's going to be 174 divided by tangent 42. Press enter. So 1 decimal place, 193.2. So going back to this problem, it's going to be 193.2 feet is the distance between building A and building B. Okay? You're not going to get any more problems that look like this one. This one was a little bit messier, but a good reference problem would be problem number 5 to go ahead and finish off the homework. All right. These are tricky. So if you are struggling, schedule a meetup with me on Wednesday, and we can go over these word problems. On Tuesday is just a review. So I want you guys to nail these word problems because next week on Wednesday is our trig unit exam. So be prepared. If you're struggling, ask tons of questions. All right, take care, guys.